So good morning to all. So in today's class we are going to learn about a sensor interfacing with microcontroller. So before knowing that, what we have to know, what are the sensors. So sensors are the electromechanical device that will convert the physical world parameters into a corresponding electrical signals. So what are the physical world parameters around us are temperature, light, humidity, moisture, pressure, light, air quality also we can monitor, uh, pollution also we can able to monitor with the help of the sensors. So normally if you want to develop a small project, there three things we need. One is sensors to communicate with the physical world and your controller and external device. So we need to see the values of the physical world, so that can be either denoted using an LCD, or it can be a 7 segment display, or it can be a just indication of an LED or a buzzer. So the outside, so these are the devices can connect. So I need a simple C code in order to link all the three things. So before going to the actual sensors working, we are just giving a topic to discuss, like for agricultural monitoring. I am having a small field. I want to monitor the field using the sensors. So what are all the sensors needed for that is, you can also take a paper and write down some of the sensors in order to do this particular work. So number one, a temperature humidity sensor, air quality gas sensor, light sensor, soil moisture sensor, IR sensor. Temperature is, we need for a particular plant need to grow in ambient temperature. The temperature should be maintained constant. It should not go high or low. And humidity also plays a major role. And air quality, for pollution control we can use air quality sensor. Light sensor, adequate light is needed for a plant growth. For that, light sensor, whether it is available or not, we can able to detect. Moisture sensor, the moisture level is not too high and too low. Based on that, we can able to open the valve of the water or close it. IR sensor, for protection purpose. I am having a field, I can connect the IR sensor at the entrance, so that any external intruder or animals, if it is entered, I can get to a buzzer or any other message, so that I can protect my field. So this is one type of a group of sensors needed for a particular application. Then if we go for human health monitoring, if you think about if I need to measure the parameters in my body, so what are the things I need? A temperature for my temperature calculation, heart rate sensor, or if I fall or something else, what the sensors will give, in which direction the person has been fall, whether it is forward fall, backward fall, sidewards, so that they can able to find out where the maximum wound has happened, whether it is the back head or front head. So many sensors are available for different purposes. And coming to the broad classification, it is digital and analog sensors. Digital will give the values in the range of 1 and 0. Analog, it's an analog, it varies with time. So what makes this both different is, digital sensors is also an analog sensor if doesn't have a comparator. It's a simple interview question also you can prepare, whether both are same or different. Which makes both are different is a comparator circuit which is present in digital sensor. That comparator, what it will do, it will compare the input values based upon some threshold. If more than the threshold, it will give the values as 1. Less than the threshold, it will give us 0. That is the digital sensor concept. Analog sensor, whatever the values we are getting with respect to time, that will be transmitted out of the sensor. So best example for IR sensor is, digital sensor is IR. The other one is for temperature sensor, LM35. So this is a block diagram of an IR sensor interface with microcontroller, and here I have connected pin 1.0 as a output, and VCC ground is simple. So here, if any obstacle is coming to the IR sensor, the obstacle is detected. That will be a message will be written in the LCD. If not, there will be no obstacle is detected. So coming to the circuit pin diagrams, so three pins already we know, VCC, ground and output, and two LEDs, power LED and obstacle LED. and IR receiver and an IR emitter LED. So IR emitter LED will be emits the LED. If there is any obstacle, that will be received by the IR receiver. If you see in this diagram will make sure whether it is very clear to understand. In the first diagram there is no obstacle, so your detector won't detect any LED. But in the second case there is an obstacle, so we will have a object is reflected by this obstacle. If you see here, I have not given the entire program, I just given the main program of the full thing. Here your IR sensor is connected to P1.0, that is port 1.0 pin, and coming to the while loop, if IR value is equal to 0, then it means like obstacle is detected, so that will be an LCD string will be displayed, or else nothing will be displayed. So command 0 cross C0 is already discussed in LCD video. We just go to that and just see what is the command C0 meant for. And coming to LM35, we know that LM35 is a analog sensor. Analog sensor directly can't be interfaced with your microcontroller. Instead, we need an interface that is called as your ADC module. So this ADC is a 8 channel 8-bit ADC. So 8 channels, I can able to connect 8 different LEDs, 8 different ICs, and 8 bit of data will be coming out of your ADC. That will be taken care by your microcontroller. So whatever the temperature value, that will be displayed in your 16x2 LCD. So with this we are completing our sensor module with your microcontroller. Thank you.